So we are going to look at the business application side of things. So in the architecture of tokens, we're going to look at how tokens can help to govern actions through property rights. And also when we have proper structure of tokens, when we show people, okay, these are the different building blocks that make up the token. This is very important because firstly, it's important in the design, and people know what goes in. And secondly, it makes it a lot easier to trust the token, to trust that, okay, this is how the token is designed because these are the building blocks, and then it's easier to find valuation for the tokens, or easier to define the valuation of the tokens. And something about trust is that it makes people feel a lot safer to want to transact with this token. And you transact with this token on chain. If you go back again, we talk about market design, and we talk about safety in market design. This is one of the example. We're just kind of combining them together. So helping your brain to link them up. How token design is related to safety in market design. So we are looking at property rights. We talk about property rights just now. The rights to the token, or rights to identity, and the different building blocks that you can play around with in property rights. And then we're looking also at distribution structure. So property rights is the more micro view, the more specific. Okay, this is the specific token. These are the building blocks of this token. And we also want to understand the structure of tokens in general, the macro view. So how your tokens will be distributed. It could be an initial distribution. So the macro view will be the initial distribution, and say that, okay, we have X number of tokens, 10% will go here, 20% there, 30% there, 40% here, and that will be the main structure. And then as you mint more tokens, how the tokens will be distributed. The other way of token distribution is the more micro view, which is every time a token is minted, how is it being distributed? Or when we talk about transaction fees just now, every time a new transaction happens and transaction fees are incurred, where do the transaction fees go? How are they being distributed? Is it distributed by the amount staked, or the other kind of duration staked, or the big players, or master nodes, or everyone gets to be distributed equally? So these are the kind of things that we want to consider. And lastly, we're also going to look at algorithm, the math, and code, because all these are just concepts, right? Are just design kind of variables that we want to implement into the token. But ultimately, the real test of whether these things are implemented is in the code, it's in the algorithm, it's in the mathematical formula. So that's something that we want to look at. So when we talk about property rights, we're looking at the economics of property rights, like the claim rights, ownership rights, rights to participate. So the economics of property rights. We are also looking at, this is a new taxation model called Harberger's taxation. It's by an Austrian economist, where his research is all about taxation. So he's looking at new forms of taxation. So now usually tax is being assessed. So tax can be 10%, and 10% based on a value that's defined by people. So a value that's defined by the property agent, a value that's defined by your company, so your income, and then your tax upon that, or value of an art piece when you pay for auction, and then you have to give them tax or something. So tax is usually calculated based on a price that's kind of set by the market forces. And now we're looking at a new form of taxation where we get to calculate tax based on a self-assessed value. So I feel that this is worth this amount, and I'm going to pay taxes based on it. And so this changes the concept of property rights a bit. We're going to look into that a little bit later. And it's a new innovative business model or new business idea to change the way we see taxation, or we see how to price items. And lastly, it's representation of identity and rights of their identity. And when we talk about identity, again, it could be a person, art, digital representation of something. So identity is really a general thing, and it could represent a lot of other other types of identity. And then the rights that they hold, or the thing holds. When we talk about distribution, we are looking at distribution at 2 stages. The first one is the initial stage. So we look at initial allocation, lockup period, amount locked up, what's the expectation of them entering the ecosystem. We are also going to look at conviction state inflation funding. So it's a new funding, continuous funding model. We're going to talk about that in the next session. And the other time period that we want to look at is just right after the initial phase. So between the initial phase and mass adoption, that period of it just understanding what the market is like. So we also want to look at, block time, block reward, minting new blocks, what is the reward, what is the time taken, so that we can understand the distribution of it, and token bonding curves. We talked about that last session, the minting and burning of new token supply. And lastly, we're going to look at a little bit of math and code. We're going to dive a little bit deeper in the next session. The next session is the last session, and it's going to be a little bit more math heavy. In fact, that's probably the first time I'm going to show you a lot more math. And we're going to understand, we're going to break tokens down into its code and understand why they're like that and what do they mean. So it really depends on the algorithm of the project. And something to be, something that's very helpful is usually when it's peer reviewed, when the code for the token, the code of the token designer or the engineering aspect of the token is being audited and things are not taken for granted. So what I notice is that sometimes people just have an assumption that tokens, the model or the formula is just like that because someone else has done it, but no one else has verified or audited the base formula, but it's being applied and used in all sorts of ways. So that's something that you should not be taking for granted, and that's something that should be audited. And the most common math formulas used are logarithmic logs, log function, exponential functions, geometric series, as well as linear functions. We talked briefly about them in the last session, remember, with all the graphs and the moving graphs and how the shape changes and the graph moves up and down. So we use 4 of them: log, exponential, not geometric, but log, exponential, and linear functions. We also introduced 3D graphs, but right now for the token models, they're just primarily looking at 2D graphs.